What's your name and project title?
So my name is Matthew Gootman, and my project title was Benchmarking Space Charge Simulations. My mentors were Adam B. and Michael K.
And what was your project about?
My project was about probing a particular particle accelerator simulation software's ability to handle extreme input particle distributions.
And how did you do so?
So I gave GPT, General Particle Tracer, a wide range of ellipsoids with different aspect ratios. By aspect ratio, I mean the ratio of the length along one axis to the width along another. And the range of aspect ratios that I gave GPT was from 0.01 all the way up to 100. And for each ellipsoid, I would have GPT calculate the electric field inside of the ellipsoid along the z-axis and radially in the xy plane. And each time I would compare GPT's output data with theoretically determined values, and that's how I would gauge GPT's performance.
And what were your findings?
I found that GPT fails to calculate the electric field accurately along radially in the xy plane for low aspect ratios, and it fails to calculate the electric field accurately along the z-axis for high aspect ratios. And going further from that, we then asked, how could we make GPT better? How could we improve the simulations? And in order to improve the simulations, we increased the size of the initial bounding box that GPT uses when conducting space charge simulation.
So what is space charge and how does GPT simulate it?
So space charge is simply the approximation of thinking of a discrete particle distribution as a continuous distribution of charge rather than a bunch of little particles. And the way that GPT handles space charge is that it'll first look at the particle distribution that we have and then make a bounding box that surrounds all of the particles. And then from there, it'll divide this bounding box that contains all the particles into a grid. And for each box of this grid, it'll calculate the charge density. Now from there, it solves a Laplace's equation for each box to determine the potential in each. And then, taking the potential, it calculates the electric field in each box. And the way that we were able to get our simulations to improve and to improve GPT's range of accuracy in the plane of aspect ratios, what we did was increase the initial bounding box size. And here's why that worked. Because in reality, you have to go, it's the limit as the distance from charges goes to infinity that you find a potential 0. But for GPT, it takes this initial bounding box boundary to have a potential of 0. And so the further this zero potential is from the actual charges in the bounding box, the more close to reality the simulation is going to be.